All right, so for the test score review, your first question just wants us to graph this, y equals 1/3 x. So what I'm going to do, I'm going to go plug that in my calculator and see which one of these four pictures I get, okay? But if you remember, we said that when you graph fractions like this exponentially, they look like they're going downhill left to right. So let's go graph that on our calculator. All right, so y'all just gonna go to my y equals. So the 1/3, I would just put in parentheses 1 divided by 3, close parentheses, and do my exponent of an x. So that's one way you can put it in. So I'm gonna show you the other way using a fraction. So I'm gonna clear this out. The other way is to hit the green button alpha in the y equals, and then hit enter for number 1. And that'll put it in fraction form, so you can come in and put your 1/3. And then arrow right and use your exponent and put in your x. So we just want to see the graph of it. So it does go downhill left to right, but notice it does not cross the x-axis. So let's go look at them pictures. So C and D both went downhill left to right, but y'all look at C, it goes way below the x-axis. And our graph did not. So on that one, we would have to pick D and then go to the next question. So I want to keep the first three on MATLAB here because they're all graphing. And then I'll go back to using my pad, okay? So they want us to graph this one on MATLAB and describe how it can be obtained from a graph of a basic exponential function. All right, y'all, this is what f of x equals 2 to the x minus 2. So first thing we got to figure out is what is that minus 2 doing to the graph? And y'all, if you remember, when we attack the x like that, if we subtract, it moves it right. If we add, it moves it left. So this is going to move right 2 units. So we want to come down here and pick A, B, C, D, which one went to the right. So we would pick C, and then in the box, ours has a base of 2. So we would have to put a 2 in there for our base. Then what you do, you're going to come down here and click the graph to enlarge. So first thing, choose the second tool on the second row for exponential tool, and then click anywhere on the graph. It's going to put it in the center. So we went right 2 units. So we would come down here on the horizontal and move that to a positive 2. And y'all remember, most important thing, on the very bottom of that box that says base, you got to go down there and change that base from an E to match the base of your problem, which was a 2. And then once you do that, hit save, and then we'll go to the next question. All right, y'all, this is doing the same thing on number 3. So we're going to describe how it can be obtained again from the graph of a basic exponential function. So down here, we're going to start with the graph of y equals 2 to the x. We're going to shift it blank 4 units. So the 4 is up here being added to that x. So y'all, since that's added to the x, that's going to move us left 4 units. And then the -5 is at the end of the function. That's either going to go up or down. So since that one's negative, that's going to go down 5 units. All right, then I would come down here once again and click to enlarge my graph. So remember, start with your exponential tool, click anywhere. So remember, +4, we move left, so that would be a horizontal. We're going to move that left to -4. The -5 at the end was a vertical shift of -5. So we go to the vertical, move that to -5. And then remember, down in the left corner for base, replace that E with a 2, since that was what the base of my equation was. And then we would save that and then move on to the next one. Y'all, the most important thing on those number 2 and number 3 is to change that base on that graph when you pulled it up, okay? All right, so I'm going to go back to the pad now, and I've got all the rest of these written down. All right, so I'm going to start with number 4. So number 4 was the word problem. It says, on Melissa's 6th birthday, he gets a $6,000 CD. That earns 5% interest, compounded semi-annually. All right, so then they say if the CD matures on her 13th birthday, how much money will be available? All right, y'all. So this is where I use the formula with y'all. We had a formula that said A of T equaled P times parentheses 1 plus R divided by N, all raised to the N times T exponent. So we just got to plug all this in and see what we get for the amount that'll be left after T years. So y'all, here we go. P was our principal balance. So she started with $6,000. Then we got parentheses 1 plus. R was my interest rate. So R equals 5%. I need that turned into a decimal. So what would y'all put on 5%?
Wait.
Oh,
0.05.
0.05. There you go. So put that 0.05 up here. N is the number of compounds. So it got compounded semi-annually. So what would y'all put for your N?
2.
All right, so that's going to be 2. So we're dividing by 2, and then our exponent will be 2 times our T. So remember, T is the time in years. She got it on her 6th birthday, and let's see, it matured on her 13th birthday. So we would just come in here and do what? 13 minus 6. And that'd give me a 7. So that right there will be 2 times 7, okay? So let me switch to my calculator so we can figure this out. And they want it rounded to the nearest cents. So when they want it rounded to the nearest cent, that'll be 2 decimal places. So y'all, let's go punch this in. All right, so I'm gonna quit this screen by hitting second mode. All right, so we had 6,000 parentheses 1 plus 0.05 divided by 2. Those are parentheses. And then my exponent was 2 times 7. All right, y'all, so let's round this to the nearest 2 decimal places. So we're going to get 8477 point, let's see, we're rounding to the 84. So the 4 has a 2 after it, so that's going to stay at 84. So we got $8,477.84. Okay, so that's the trick on that, and just plug everything into your formula, punch it on that calculator, and see what you get. And just remember, round it off 2 decimal places on that. All right, 5 wants me to find the logarithm, and I've got probably 4 or 5 in a row. This one is a log base 10 of 0.001. All right, so let me go to the calculator. Now remember, that's a log base 10. The log that's down here by the 7 on your calculator, if you push that log, that's a log base 10. It's understood to have a 10 there. So then just punch in your 0.001. And anytime you do the log of a decimal like this, you should get a negative number. And there we go. We got what? A -3. Okay, y'all, so I'm just gonna go back now. All right, so -3 would be the exponent that you would raise 10 to get me a 0.001. Number 6, find the logarithm. Log base 3 of 3 to the 2nd power. Now, I'm hoping y'all know that what that is quick off, because we got a property that we had when the log of a base matched the base of the result to an exponent. But if you forgot that, I'll show you how to punch that on your calculator. So I'm going to go to my calculator. Now, since that had a base of 3, I would use the log base. So hit math, arrow down to log base. Once you got log base, hit enter. All right, so my base was a 3. I'm going to arrow over. And then I had a 3 to the 2nd power. So put my 3 exponent 2. So y'all, what's the answer of this before I even hit enter?
2.
There you go. It's going to be 2. Good job. So remember, when the base matches the result to an exponent, the answer will always be that exponent. So good job. All right, y'all, number 7, find the logarithm. So a lot of this test is just pushing stuff on that calculator. All right, y'all, this is a log base 8 of a 2. Now, when the base of the log is bigger than the result, you should get a fractional exponent. It'll pop up on the calculator as a decimal, but remember, turn that decimal into a fraction. Because in the answer box, they want you to type a fraction, okay? So on that one, since my base is an 8, I'm gonna go to math and arrow down to log base again. Hit enter. 8 was my base, and then y'all arrow right and put in your 2. Now remember, when I hit enter, it's gonna give me that decimal, but turn that into a fraction by hitting math and enter twice, so that we get a 1/3. So that was what, a 1/3. All right, I can put number 8 right here. 8 wants me to find the logarithm again. And it has a log base 30 of a 1. So y'all should all know what this is. No matter what this base is, if that result is a 1, there's only one exponent that has the power to turn any of these bases into a 1. So what is it?
0.
Definitely 0. Hey, y'all, so remember, no matter what that base, if that's a 1, you're going to have a 0 there, okay? All right, then starting at number 9, they wanted us to start, so number 9, convert to a logarithmic equation. Okay, so this is where they're giving me 10 to the 6th equals 1 million. So since I'm converting to a log, I got to write log. My base is the same thing as the base of the exponential, which is 10. So bring down your 10. My result is that 1 million. Remember, log base 10 of 1 million equals an exponent of 6. So rewrite that one and be done. Now, y'all, same thing. So they're giving me 2 that I'm going to convert to logarithmic. Then they're going to give us 2 that we convert to exponential. All right, so for number 10, they're giving me e to the 5th equals p. So once again, I'm going to start out with my log. And then want to write my base, which is that e. So bring down your little subscript e. My result is the p, and that's going to equal the exponent of a 5. So y'all, here's a question on this one. I can actually, it should take that answer, but there's another way I can write a log base e. Y'all remember?
LN.
ln. So y'all could do ln of p equals 5. All right, y'all. So now we're going to convert to exponential. So they'll give me a log, and I want to convert it over to the exponential. So for this one, I got a log base 2 of a 4 equals 2. So going in reverse from these problems, okay? So your base is the 2, so you're going to write that 2 first. The exponent is the 2 on the right side. And guess what? 2 to the 2nd power equals that result of a 4. And y'all just make sure on number 12, since they're giving you numbers, it's got to be a true statement when you're done, okay? All right, convert to exponential. Log base P of R equals negative Y. So you get good at doing stuff with numbers and they always got to throw the letters at you, right? But y'all, you're doing the same thing. The base is the P. What's my exponent?
Negative one.
All right, so that's going to be the negative Y, and guess what? That's going to equal that result of R. All right, so like I said, 9 and 10 going from exponential to a log. 10 and 11, you're going from a log to exponential. All right, y'all, let me turn this paper. So 13 tells me to use the calculator to find a natural log. So use a calculator to find the natural log. Now remember, by natural log, they're just talking about the ln. So they want us to figure out what ln of 688.7 equals. And we're going to have to round this 4 decimal places. So anytime you get a decimal, it's going to go out 4 decimal places, okay? So I'm just going to go to the calculator here. LN button is right on the left side, so I'm going to hit the LN by the 4. Punch in 688.7 and hit enter. All right, so let's see, 4 decimal places. That'll be what? 5, 3, 4, 8. 8's got a 0 after it, so the 8 will stay at 8. So this gives me 6.5348. And remember, the trickiest on these ones is getting that rounded, okay? All right, now 14 says find the logarithm using change of base. All right, so for us, when they say use a change of base, that's when we want to use the log base in our calculator, okay? So that's the log base in our TI-84. And y'all are giving us a log base 8 of 18. And once again, they want it rounded off 4 decimal places. So I'm going to go to that calculator. So to get log base, I'm going to hit math and arrow down. Hit enter. I had a base of 8, so I put my 8, and then I'm going to arrow right to put that result of an 18 in. And hit enter. All right, so let's see, we got a 1.3899. Oh, wow, that 9's got a 7 after it. So that 9's rounded up to a 10, which is going to round the next 9 up to a 10, which is going to round that 8 up to a 9. So y'all, that's going to give us a 1.3900. Now y'all, let me show you a trick. If you're a little weak at rounding off, I can hit that mode button on my calculator on the top, hit the mode button, and arrow down where it says float. If you go right to 4, this is where it sets how many decimal places you're going to round off to. So notice I've got the 4 highlighted now. So when I click that screen and hit enter, it'll round that answer to 4 decimal places. And there's that 3900, okay? Now, after I did my problem, I'd probably go back to my mode and put my arrow down to float and highlight that again, okay? But yeah, so once I do that, it'll put it back in more digits. But to round it off, just hit mode and arrow down to 4 on that, okay? All right, y'all, 15. Express as a sum of logs. So if I'm expressing something as a sum, they're going to give us a product. And y'all, they give me a log base 13 of 13 times 169. All right, so express it as a sum. So we're going to distribute the log 13 to both of the factors and put a plus in between them. So that we get a log 13 of 13 plus our log 13 of 169. All right, it's written as a sum, so we're done. 16 says express as a product. All right, y'all are giving us a log base m of z to the third. So y'all, to express something as a product, we had one move that we did to this log. And that move was to take this exponent and move it to the front. So if we move that exponent to the front, we get 3 times the log base m of z. Okay. So that's all they mean by as a product. Take this exponent, bring it down, and multiply it by that log m of z, okay? All right, 17. Rewrite as sums or differences of logarithms. All right, y'all, they're giving me a log base b of parentheses x to the 9th y squared and a z. So here's the thing. The only way to get differences is if you got a quotient or division. So since these are all being multiplied, all these are going to end up being sums, okay? And we're going to distribute the log base b to all 3 of these factors. So we'll start out by doing our log base b of x to the 9th plus log base b of y squared plus log base b of a z. Oh, and y'all, guess what? I got one more move I could do to that technically. Well, we got to do it. So what's that last move?
Are we moving the exponent to the front? Sorry, I lost my voice.
So I got 2 of them. I'm going to have to move them 2 exponents to the front. Good job. So 9 log b of x. Bringing that one down, I get plus 2 log b of y. And then just bring down my last one, which is my log b of z. Okay, y'all, that's it on those. Multiplication rewrites is addition, okay? Now 18 is the one I told y'all to star. So we're going to express log base B P to the 4 Q to the 6 over M to the 5th B to the 7th. We're going to express this in terms of sums and differences. Of logarithms. So basically the same thing 17 wanted. But here's the thing on this one. Remember, if it's on top of the quotient, the stuff on top, when we rewrite it, will be positive or added. The two things on the bottom, the M and the B, since they're on the bottom, when we rewrite them, they will be subtracted, okay? Now we're going to distribute the log B to all 4 of those. So I get a log base B of P to the 4th plus a log base B of Q to the 6th. Now the next 2 factors are on bottom, so we'll be subtracting a log base B of M to the 5th minus a log base B of B to the 7th. Okay, y'all, so here's the thing on this one. 3 of these exponents I'm going to bring down to the front. This log base B of 7, what does that equal in the long run?
7.
It's definitely going to equal 7. So y'all, since this equals 7, I'm just going to bring it down as a 7, and that log base B of B part will be gone. All righty, so bringing the 4 down, you get 4 log base B of P plus a 6 log base B of Q minus a 5 log base B of M minus 7. And y'all be careful. They'll have an answer where they bring that 7 down, but they'll have a log base B of B behind it. Remember, that's not simplified because log base B of B equals 1, okay? And we always have to get the most simplified form. All right, 20 says simplify.
You mean 19?
And let's see. So simplifying, I'm going to sort of rewrite them like I was doing here, but I'll go the other way, okay? And the thing about simplifying, remember, if they got subtraction, we write that as a quotient. If they got multiplication, we write that as a sum. All right, y'all, I got this. ln of x squared plus 6x plus 8 minus ln x plus 4. So this is being subtracted. So when I rewrite it, it's going to look like a quotient. So we pull out that ln and write it first. The positive factor goes on top, x squared plus 6x plus 8. The factor being subtracted goes to the bottom. That would be your x plus 4. So in order to simplify this, we got to be able to factor the top of this and see if we got any factor on top that'll cancel with that x plus 4 on the bottom. So y'all, let's try to factor that top. We got an x squared. That's going to be an x and an x. What 2 signs would y'all put in here?
2 and
Positive.
All righty, what factors of 8 will give me 6?
2 and 4.
2 and 4. All right, so good job. So that means the x plus 4 factor cancels. So y'all, here's the thing on this one. When you write this final answer, you gotta keep that x plus 2 in parentheses. Okay. And that's just because this fraction went away and the answer needs to realize that both of those are being affected by the ln. So in this case, you must use parentheses. So I'm going to write that one on this one. For that answer. All right, that didn't go down far enough. There you go. All right, y'all ready? So that puts us on what, number 20? And I'm gonna move that back up right there. All right, 20 is the same thing as 19. They say, but they give you different instructions. This one says express as single log and simplify. Okay, the 19 just said simplify. This one actually tells you express it as a single log and simplify. Okay. So I got a log of x squared plus a x minus 30 minus a log of x squared minus 36. So first of all, write it as a single log being subtracted, so it's going to look like a quotient. So bring out your log. The top will be the x squared plus x minus 30. The bottom will be the x squared minus 36, since this factor was being subtracted. So y'all, both of these got x squared, so we got to factor both of these. And since I'm going to factor, I'm going to put them both in parentheses. X squared on top is an x and an x. Last one's negative, so we got unlike signs. So what factors of 30 subtract and give me 1? That would be 6 and 5. 6 is bigger, so it's positive like the middle. And the 5 is negative. X squared minus 36 will have an x and an x. One will be positive, one will be negative. And y'all, the easiest way to do this one, on your number 20 for the bottom, you're going to have an x plus and an x minus. Figure out what the square root of 36 is. Because that's the number that minus itself would give you a 0. Remember, this is like a 0x in the middle since it's not shown. So those factors would be 6 and 6. So look, just like 19, you cancel out a factor. So my final answer, now, since this is a single fraction left, on this one, you can actually write x minus 5 over x minus 6. You don't need parentheses on this one because it came in the form of a fraction and it knows to take the log of the whole fraction, okay? So this one does not need parentheses on the final answer. All right, so I wanted y'all to see the difference. 20, you didn't need parentheses. 19 you did, okay? All right, y'all, the rest of these want me to solve for X. So number 21, we'll start out with it. I got 6 to the 8x equals 216. So everybody's number 21, you're going to be able to rewrite the right half as that base raised to an exponent. So what I'm going to do is rewrite 216 as 6 to the third. Because 6 times 6 is 36. 36 times 6 is 216. So y'all, you would bring down your 6 to the 8x. That's going to equal 6 to the third. Well, remember at this point, if the bases match, so our bases match. So remember, if these bases match, that means these exponents have to be equal. So you're going to come down and say, well, hey, 8x has to equal that 3. And then we're just going to solve it for the x. So this one, y'all, I'm going to what? Divide both sides by 8. So that cancels, and x is equal to a 3 over 8. So what happens? You put a 3 over 8 up here, the 8's cancel, you get 6 to the third, and y'all guess what? 6 to the third is 216, so that will check out, okay? And y'all, these equations were the things we did in our last class last Wednesday, okay? All right, once again, we're going to solve. But this time they're giving me 3 to the x equals 10. So y'all's number 21 will be able to rewrite. Your number 22, we're not going to be able to rewrite. I can't turn a 3 into a 10 by multiplying. 3 times 3 is 9. 9 times 3, 27. So since I cannot rewrite this one, I'm going to take logs of both sides. So I'm going to have the log of 3 to the x equals the log of 10. Now remember, the only reason we did this was so we can take that exponent and bring that exponent down to the front so that we get x times log 3 equals log 10. So if I can rewrite the base, I'll rewrite it, and then I set the exponents equal to each other. If I cannot rewrite the base, I take logs so that I can get that exponent brought down. Then my last step, divide both sides by that log 3. So I get an x times log 3 divided by log 3 is going to equal my log 10 divided by log 3. So those cancel, giving me my x. Now, I'm going to go punch that on the calculator, but y'all remember, close those parentheses on these logs when we punch it in. And let's see, we're going to have to round it 4 decimal places, okay? So here we go. I'm going to go figure out what a log 10 divided by log 3 equals. All right, so there's my log. Punch in my 10, close parentheses, and then divide by log. Put in my 3 and close parentheses. All right, that's one way, but y'all remember, you could also use this alpha y equals and hit enter for numerator denominator. Up here, you can put a log 10, close parentheses, and then arrow down and do your log 3, close parentheses. Either way you want to do it, okay? You got to close the parentheses either way. Hit enter. So we're going 4 decimal places. So that'd be the 0959. A 0 after the 9, so that 9 will stay. so that we get a 2.0959. Okay. Or if you remember, y'all could have went to the mode and put it back on 4 and it would have rounded it off to this, okay? All right, so those were the two exponentials. Next, they're going to give us 3 logarithms. And y'all, these still say solve for x. So I got a log base 4 of 5x minus 9 equals 2. So I got a single log equal to a number. My first step is to rewrite this as exponential. So the base is 4. Exponent is 2. And that's going to equal our result of a 5x minus 9. All right, so let's figure out 4 squared. That's 4 times 4. So it's going to give you 16 equals 5x minus 9. All right, y'all, so we're just solving for the x now. So we're going to add 9 to both sides. That's going to give me 25 over here, equal to my 5x. And then our final step, divide both sides by the 5. So I got a 25 divided by 5 will equal 5x divided by 5. So let's see, that cancels, giving me my x. And then 25 divided by 5 gives us our 5. Okay, so 23 will be just like mine. Your base exponent equals that result. (24), solve again. So like I said, the rest of these are just solved. Log base 2. C plus 36 minus log base 2 of C plus 6 equals log base 2 of a C. All right, I got 2 logs on this side. So the 2 logs on this side, I'm going to write as a single log. Now remember, these are being subtracted. So when we rewrite it, it'll look like a quotient. So we'll have a log base 2. C plus 36 goes on top. This factor being subtracted, that C plus 6 goes to the bottom. That's going to equal the right side, which is a log base 2 of a C. So what happens? You got a log on this side equal to a log on that side. Those log bases match. So y'all think about this. When these log bases match, that tells me that this result equals that result. That means that the C plus 36 over the C plus 6 equals the C on the right side. All right, so let me pull this down a little here now. So what I do to this is I treat that C like it's got a 1 on the bottom. And I'm just going to cross multiply this. The C plus 36 multiplies by 1 on one side of the equals. Well, that's going to be C times 1 is C, plus 36 times 1 is 36. That's going to equal the other side, which is this bottom times that top. So the C times C is a C squared plus 6 times c is a 6c. All right, y'all, on your number 24, just like mine, you're going to end up with a c squared. Anytime we got c squareds, we need all this stuff on one side equal to 0. So I would come in and subtract a c from both sides, and I would subtract 36 from both sides. So that this left side is now 0. Then we get our c squared. 6 minus 1 gives me 5c, and then minus my 36. All right, y'all, time to factor that. Or if you like using the quad formula, you can do the quad stuff on this one, okay? Use a 1, 5, negative 36. All right, but I'm gonna factor it. I got a c and a c because of that c squared. That's negative, so I got a positive and a minus. Okay, I'm looking for factors of 36. That'll subtract and give me 5. That'll be 9 and 4. 9's the larger number, positive like the middle. And the 4 will be negative. Did I hear a question? Okay, so I'm gonna bring that up and finish it. So remember, set both of these equal to 0. So I'll have c plus 9 equals 0. C minus 4 equals 0. See, on the first one, I'm just going to subtract 9 and finish that one. So I get c equals negative 9. The second one, I'll add 4 to both sides. And I get c equals positive 4. Now, if you'd have put this in the quad at this point, use the quad program or the quadratic formula, it would have gave you negative 9 and 4. So the question is, what's my answer?
4.
Oh, good job. Because remember, y'all, we cannot take negative answers. So let's say we cannot take the negative solutions. All right, good job, because that's really fresh on y'all. So remember, cannot take the negative answers on number 24 or the one I'm about to do, number 25, okay? I'm gonna let y'all catch up just a second there. You know, I will say number 25 will be really similar to this one, except remember, this one was being subtracted, so we wrote it as quotient. My number 25 is going to be added, so it'll look like a product. All right, y'all, here we go. Same thing on 25. Solve for x. I got a log base 3 of x plus 12 plus a log base 3 of x minus 12. That's all going to equal positive 4. All right, 2 logs on the left side, so we got to rewrite as a single log. All right, so like I said, they're being added, so we're going to write it as a product. So bring down your log base 3. We're going to have x plus 12 times x minus 12. That's all going to equal the right side, which was a 4. So the thing about this, when you only got the log on one side, you don't have a log on this side, so we can't use that log basis on this one. So what I'm going to do to this one is rewrite as exponential. So y'all, here we go. What's the base?
Is it 3?
All right, how about my exponent?
4.
All right, good job. And then that's going to equal that result, y'all, of what? An x plus 12 times your x minus 12. All right, so first we want to figure out what 3 times 3 times 3 times 3 equals. So let's see, that give me what, 3 times 3 is 9, 3 times 3 is 9, 9 times 9. That's going to give us 81. And then I'm going to FOIL this, but remember, these are conjugate pairs again. And anytime I got these conjugate pairs, I'm going to shortcut on my FOIL. So the shortcut is the first two x's times each other. So x times x gives me an x squared. And then it's minus the last two together. And 12 times 12, 144. So y'all, this one's got an x squared term. But remember, on number 24, when I did it, I had an x squared term, my x term, and a number. So I factored it. Since this one's got the x squared terms and a number, I always get the numbers on one side and take square roots, because that'd be easier than factoring. So to get everything on one side on this one, I'm going to add my 144. So let's see, that's what, a 225 is going to equal my x squared. All right. Turn x squared into an x. We're going to take square roots of both sides. So remember, the square root is going to come out as a plus or minus. All right, so what is the square root of 225?
I think it's plus or minus 15.
There you go. And then that's just going to give me my x. So y'all remember, this means x equals 15, x equals negative 15. On this answer, you cannot use that plus or minus 15 for the answer, right? Because my only answer is going to be what?
15.
Positive 15. So remember, cross out that negative. And that's why you can't use that plus or minus, because it counts for both of these answers, okay? So yeah, that one will just be the positive 15. So y'all, that's your test 4 right there. Okay. I tell you, the biggest things on this you got to remember is when you're using that graphing tool in MATLAB, change that base at the bottom, because remember, by default, that's got an E sitting down there, okay? All right, y'all, so let me quit my share here. All righty, do y'all have questions? All right, so remember, here's my schedule. Wednesday night, all I'm going to do with y'all Wednesday is going to be catching y'all up on homework or anything. So if you don't have any questions about homework, Wednesday will be like a free night for you. Because I'm going to review for the final exam next Monday. And the reason I do that is I didn't want people to get mixed up with test 4 material and then get messed up with that final exam material, okay? So this week, I want y'all to finish out everything through test 4, and then we'll worry about that final exam Monday. All right, so I got a chat. Is the review a requirement? Remember, the review counts as the quiz grade, okay? So yeah, do that review because it counts as a quiz grade, like 5% of your grade. But yeah, you'll probably blow through that and then blow through that test and be good. All righty, y'all. Remember when the test and the review also, when you write LN and log, it should highlight them and make them bold for you, okay?
I have a question,
Okay.
or I guess a problem. On number 6, when I find that with my calculator, I keep getting 1.
On number 6.
Mm-hmm.
Okay, so you're doing, so number 6 is log base 3 of 3 to the second power.
Right.
Okay, so let me share that real quick on my calculator. So it's giving you what answer?
1. And I've done it twice.
Okay, so you got your calculator with you?
Uh-huh.
All right, so we're about to push it in together, okay?
Okay.
So on that one, I would go to math and go down to log base. And hit my enter.
Mm-hmm.
All right, so number 6, we had a base of 3, so we're going to put in our 3, and then we're going to arrow right.
Mm-hmm.
And at that point, we're going to put in our 3, hit the V, upside down V under clear for my exponent, and then put in my 2. So is yours looking sort of like mine?
Yeah, I was putting the exponent outside the parentheses.
Oh, and you know why? Okay, because it was doing order of operation. So let me show you the difference. If you did that, let me clear that. Go to math. So I'll show you what happened on that. So let me go down and get that log base again. So we had a base 3, and then you had a 3 here, and then you went outside like this and did your exponent of a 2. So
Mhm.
what's happening now, since the 3 squared ain't in parentheses, it's going to do its order of operations, and it's going to start by doing the log base 3 of 3. Well, remember, if you punch in log base 3 of 3, it's going to give you a 1. And then 1 squared would be 1 times 1, which is why you got that 1 on that. So it was just because of the way. So notice when I hit enter, I'll get that 1 like you did. So it's just how the calculator was trying to figure out your order of operations on it. So
Okay,
yeah.
thank you.
So on that, remember, if you're going to use since it's giving you parentheses, put that 2 inside those parentheses and then shut them, okay? All righty, y'all. So let's see. I'm looking at my chat, not seeing nothing.
Do we need to take the support assessment quiz as well? Yes.
Yeah, so what it is, it's just got to be done by the end of the year. It's not going to count against you as a grade, but we use it sort of like a tool to see how much y'all learned with the support stuff. So it's not going to affect your grade in the college algebra, but we like y'all to do them just for helping us get a grip on how that support class is doing.
Okay.
Yeah, what was her question?
Do what now?
What was her question?
She was asking me about, there's a support quiz you're going to see near the end of the assignments.
Okay.
And it's just a assessment tool we use. So it's not going to affect your grades, okay? But it's got to be done. It's just 10 little questions, and it was 10 basic questions on like factoring and solving easy equations. Some of the stuff we learned in that support class, actually, okay? All righty, so I'm gonna quit my recording.